Hey everybody, Mrs. Kroll here. I'm just going to go through the Unit 1 review guide that we gave you so that hopefully I can answer any of the questions you may have. First thing though, before we get started, I just wanted to talk about a couple things here with my drawing. The drawing is wrong on this graph. This black dot that's kind of here off nowhere should be at 2, 1. And then this dot over here shouldn't be here over there. It should be moved over. So that should be at 1, 2, 3, 4, 1, 2, 3. So 4, -3. Sorry if that caused any confusion for those dots. They just kind of got shifted over in the picture. All right, so the first thing we're going to do, let's get started going over the following questions. So the first one is, what is f of 5? You can look right on the graph. F of 5 is going to end up being 6. Then we want f of 2. F of 2, is where that dot was that I needed to move. So that's going to be at 2, 1, so the value will be 1. And then at f of 4, 4, -3. Then we want the limit as we approach -7. So we're looking from the left and from the right as we get closer and closer to 7. And we have a y value of 2. Once we get to -5, left and right comparisons, those are both going to end up being 6. At 2, we're coming from the left and from the right, and we are getting closer and closer to 3. At 4, as I look at 4 from the left and from the right, they are not going to the same spot, so those will be D and E. At 0, we're going to a vertical asymptote, so that's going to end up also being D and E. But if we look at 0 from the left, that's going down, that's going to be -infinity. And 0 from the right, that part is going up, that's +infinity. 4 was also D and E, so 4 from the right, that one is getting closer and closer to -3. And 4 from the left, that is at +2. Then going out to infinity, it looks like there is a horizontal asymptote here at 0 going all the way across the graph. So as we go to -infinity, we're getting closer to 0, and +infinity, getting closer and closer to 0. All right, use the definition of a continuous function at a number to answer the following. So using the definition of continuity at a point that we discussed in class is using that calc-based language. So the first one, -7, doesn't exist because f of -7 is not defined. So f of -7 is not defined. There's no filled in hole in that graph. Now 2 is not continuous because f of 2 is defined and the limit exists, but they're not the same value. So in this one, we would say the limit as x approaches 2 of f of x does not equal f of 2. And then finally, our last one, talking about f of 4. F of 4 doesn't happen because the limit does not exist. The left and the right-handed limits are not the same. So the limit as x approaches 4 of f of x does not exist.